Geometry section 10.3. Before we start, let me just warn you that the first couple sections you may have found to be fairly easy. Rectangles and parallelograms and triangles and trapezoids are not as challenging as what we're going to do today. The difference being that, in section 10.1 and 10.2, we can give you multiple figures. I think we gave you 3 in each, whereas here we're going to focus on just one formula, one type of figure. It actually works for all regular polygons, but it's the same formula for all of them. Okay, so this is gonna be a little bit more challenging. Not to make you worried or scare you off. Just know that going in. Make sure you do all the homework problems, practice things out, show your work. Join my office hours if you have questions, and you can definitely do this. But buckle up, because it is a little bit more challenging than the first 2 sections. What I have drawn here is a regular hexagon. It is inscribed in a circle. The circle doesn't really matter. I only put it there because I want to show you that this length right here is called a radius. Okay, so a circle has a radius. Here's a circle. The radius goes from the center to the edge of the circle. Well, on a polygon, it's that same length, but it goes to a vertex. So if I take that regular polygon, and it does have to be regular, okay, all the sides the same length, all the angles the same measure, that length that goes from the center to a vertex is called the radius. Okay. Now I could have picked any figure here. I decided to pick hexagon, but I could have picked triangle, square, pentagon, octagon, 25gon. I just chose hexagon. And you could always inscribe a polygon inside of a circle, a regular polygon that is, inside of a circle, and it'll have radiuses. Radii is plural for radiuses. So here's a radius, here's a radius, here's a radius. This hexagon would actually have 6 radii. More important to the formula that I'm about to give you is apothum. Side note, some people call that apothum, but I've been calling it apothum forever, so to me it's still apothum. It always will be. And that length goes from the center to the midpoint of one of the sides. Okay, now it's showing perpendicular to. That's also a characteristic of that. Either way, it's a length that goes from the center perpendicular to one of the sides, or it's a length that goes from the center to the midpoint. Those would actually be the same thing. Now that's not always the same thing in different figures, but for a regular polygon, it always will be. Okay, so that's the apothum. And in the area formula, as we get down to here, the area of a regular polygon is 1/2 apothum times perimeter. Now again, we already know what a perimeter is. It's just the distance around. We'll need to be able to calculate that. And then the apothum is this length right here. We'll have to be given it, or we'll have to be given a method for calculating it. One more thing before we do some examples is that this is one of the formulas that we would have given you. Okay, now you're only being assessed over Socrative assessments anyway, so you can certainly have your book and notes open for that anyway. But this is one of the formulas. If we were giving you quizzes and tests, this is one of the formulas that would have been given to you. Area equals 1/2 apothum times perimeter. All right, let's look at a couple of examples. Here it says find the area of a regular polygon with 20 12-inch sides and a 37.9-inch apothum. Okay, before we get to that, quick side note. I could draw a triangle, right? And I'm going to just freehand these. I'm attempting to draw as close as I can regular polygons. There's an equilateral triangle, a regular triangle that is. I could draw a square. I could draw a pentagon. I could draw a 6-sided figure hexagon like I just did on the previous page there. Okay? Notice that the more sides I add, the more it starts to look like a circle. Now I won't try a 7-sided figure, but here's an octagon, right? Looking more and more like a circle. Well, this is asking about a 20-sided figure, 20 12-inch sides. I won't even be able to do it, but let me attempt it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. I fell a little bit short there, so I drew as best as I could an 18-gon, not a 20-gon, but I ran out of space there before I brought it back together. And look how closely that looks to a circle, okay? So I only tell you that because I think it helps with context to understand what it is we're dealing with. Yes, you can still draw a radius like that. You can still draw an apothum that would go from the center to the midpoint of one of the sides. And that's the apothem right there, and we're going to need that value. Okay? Well, lucky for us, in this problem, they actually gave it to us. It's 37.9. The perimeter, we're going to have to calculate that. That would be the sum of all of these lengths as you go around the figure. Okay? So let's actually do that for this problem. Our formula, again, is 1/2 apothem times perimeter. The work you should show on each problem that deals with this would be 1/2 of 37.9 times the perimeter. Now there are 20 12-inch sides. That would be 240 inches. And then use your calculator. You're going to likely need to use your calculator on most of these problems. That's no problem. 1/2 of 37.9 times 240 is exactly 4,548. Okay, and again, for each one of these, you should have work, this, and then answer like this. And it is an area, so that would be in inches squared. This is our new formula, 1/2 apothem times perimeter. Take a look at this one, an octagon. The radius is given here as 23.5. A side length is given as 18 feet. Here's what we can do. We can draw down and make ourselves a triangle, so to speak, an embedded triangle. And this length right here would be the apothem. We're going to need that. Okay? Basically what we need is the apothem and the perimeter. And once I have those two numbers, I can plug them into 1/2 apothem times perimeter. Okay? Now notice, this is a right triangle. If I draw down in a perpendicular kind of way, as apothem was defined, then it's a right triangle. And that right triangle, if I just blow up the sides a little bit here, would be like this: 23.5 for the hypotenuse and 9 for that leg. Right? If the whole length here is 18, then this much would be half that 9. So you can do the Pythagorean theorem and go 9 squared plus a squared equals 23.5 squared. Now I already did the math on this one, and if you solve that for a, you're going to get approximately 21.7. Now again, if you were here, I would make a big deal about this, and you've heard me make a big deal about this before. Exact values are more important, are better, not more important, they're better than rounded values. I made a big deal about this when we talked about the law of sines and the law of cosines, and I think elsewhere too. So 21.7, while that's about the length of the apothem, it is approximated, and I do have the exact value in my calculator. So as I go ahead, and again, I'll just go ahead and put this over here, 21.7 approximately. And as I go ahead and start to fill out my formula, 1/2 of approximately 21.7, and I'm putting that symbol in there to remind myself that it's approximated and that I still have the exact value in my calculator. It's going to get multiplied by 1/2 and multiplied by the perimeter. Okay, well, what's the perimeter? Here's an 18-foot side, and there are 8 of them. They're all the same length, 18, because it's a regular figure. So 8 times 18 would be 144. The apothem is about 21.7. The perimeter is exactly 144. And this is the line of work that you ought to show. Now again, on your calculator, don't take 1/2 times 21.7 times 144. And look, for right now, in quarantine, it's not the worst thing in the world if you do so, but I'm just trying to give this to you as closely as I would have taught it to you if we were face to face. The better number is in my calculator. So I'm going to take that number and I'm going to multiply it by 1/2. So I just take the number that's already in my calculator, I go times 1/2 times 144, and it comes out to 1562. (1,562 feet squared). Now, let me just roll to the answer here. Oh, I take that back. I'm sorry. They got 1562.4. If I use my answer, let me try that again. My more accurate answer, because I used the exact value 21.7, it is actually 1563.0. I beg your pardon. 1563.0 feet squared. And as I roll to the answer now, and they get, you can check this on your calculator too, and they get 1562.4. That means they did use an approximated value, 21.7. Okay, now again, not the end of the world this year, but that would cost you half a point on any quiz or test that you would take of mine, again, had you been here. So the accurate answer is better. I like 1563.0. Okay, now all that to point this out too, they did say to the nearest 10 feet squared, not tenth, 10. Okay, so that would actually just be 1560. I don't think the book does this at all. We never do that on quizzes or tests, but technically to the letter, as they said here, to the nearest 10 square feet would actually just be 1560. All right, a couple more things. Take a look at number 5 here. Find the area of each regular polygon. Notice this direction. Leave your answer in simplest radical form. Here you have a regular triangle. This is what's going to be the bulk of your questions going into the homework. Regular triangles, regular hexagons, and also squares. Because what we can do with these 3 figures in particular is we can create a special right triangle. And as I draw that radius, let me try to draw it a little bit straighter. As I draw the radius that goes from the center to a vertex, this angle right here would be 30 degrees. Okay? Now notice, the apothem is already 4. We can find the length of what would end up being the long leg of that right triangle by using what we know about special right triangles. I'll denote that in red. This length is from here to here, right? That length would be 4 root 3. I reviewed special right triangles in a previous video. If you need to look at those again, do that before you try the homework. That length would be 4 root 3, okay? Now, if that length is 4 root 3, this length also would be 4 root 3, which means the side length would be 8 root 3. And if the side length is 8 root 3 and there's 3 sides, that means the perimeter would be 24 root 3. There's really 2 ways to think about that. Number 1, you can do what I just did. Here's half a side, double it to get the length of a side, 8 root 3, and then multiply that by the number of sides, 24 root 3. Others will look at this and they'll go, okay, 4 root 3, and then there's 1, 2, 3, 4, 5, 6 of them. Okay, well, 6 times 4 is 24. 6 times 4 root 3 is 24 root 3. Either way, the perimeter is 24 root 3. The apothem is already given to us as 4, so our formula should be 1/2 apothem times perimeter. And we want to leave our answer in simplest radical form, which means you multiply 1/2 and 4 and 24, which is 48, and you just leave the root 3. This would be 48 root 3 meters squared. That's the area. And I'm still showing work and answer. Now, what if it's a hexagon, regular hexagon? You can draw an apothem like this. If there's not a radius, you should draw the radius. The apothem will be given. If there's not an apothem, you should draw it in because the radius will be given. So you're creating for yourself this special right triangle. We know that the angles on a regular hexagon are 120 degrees. That means that this angle right here is 60 degrees. Okay? And notice that the radius is given as 2. That's actually the hypotenuse of this special right triangle. 30, 60, 90 special right triangle. And if the hypotenuse is 2, that means that this length here is 1, and that means that this length right here is 1 root 3, or just root 3. Now look, I could have drawn that apothem anywhere. I could have drawn it down, but it was, the 2 inches was in the way. I could have drawn it over here with a radius. You can really draw that anywhere. I decided to draw it here so that I can make this special right triangle. Anywhere you draw it, the apothem is going to be 1 times the square root of 3. Okay? So, again, we need the perimeter. We need the apothem. I just figured that out. It's the square root of 3. And then we can plug that into the area formula. Well, the perimeter is just 1 12 times. Here's 1, here's 1. That's 2, 4, 6, 8, 10, 12. Okay? So the perimeter is 12. Our area formula should look like this. 1/2 apothem times perimeter. By the way, one of the easy things to do for students who fully understand this and would otherwise get it right is to accidentally leave out the half. Don't forget to use an accurate formula. 1/2 apothem times perimeter. Okay, now 1/2 of 12 is 6. You're going to leave the root 3 alone and do the math around it. 1/2 of 12 is 6. The answer would be 6 root 3 inches squared. Okay, now I'm pretty much done. Just one more real quick thing, just to cover every figure that you might see when it comes to special right triangles is they could also give you a square. Reminder that in a square, or excuse me, well, in a square, you're going to get a 45, 45, 90 right triangle, right? As they've shown that radius, and as I draw down to make the apothem like this, okay? In a 45, 45, 90 triangle, the relationship is root 2, okay? So from the hypotenuse to this length right here, which would actually also be this length right here on a 45, 45, 90 triangle because it's isosceles, would be 6 divided by the square root of 2, okay? Now, if they just ask for it to the nearest whatever, to the nearest tenth, to the nearest hundredth, whatever, you can take that number and plug it in for the apothem. You could take that number and multiply it by 8 and plug that in for the perimeter, okay? It would not matter. For the purposes of simplest radical form, like the last two problems were though, I would take the time to multiply by root 2 over root 2, which would be 6 root 2 over 2, which is 3 root 2. That's the number I'm going to plug in for the apothem. Let me again just list those off to the side. The apothem is 3 root 2. Now this length is also 3 root 2, and the perimeter then is 1, 2, 3, 4, 5, 6, 7, 8 of those. That would be 24 root 2. Okay, so let's plug all that in. Half of 3 root 2 times 24 root 2. Please realize that this is one continuous multiplication. It's a half times 3 times root 2 times 24 times root 2. All of those things are being multiplied. Now let me ask you a question. What's the square root of 2 times the square root of 2? Did you say 2? You know you can multiply things in any order, right? So root 2 times root 2 would be 2, and then I can multiply that by 24 and by 3 and by a half. Or how about this? Root 2 times root 2 is 2. 2 times a half is 1, and then you're just left with 1 times 3 times 24. Basically 3 times 24, which is 72. 72 miles squared. Okay, and that's done. Now, you do have a homework assignment. I'll put this in the email as well, but I just want to point this out because I don't think I'll remember to put this in the email, that when you get to problems 14 through 18, you should do the exact values as we did in this problem and the previous two. Okay? Good luck on your homework. Thank you.